Professor Pandey sir, introducing to Professor Don, and thank Professor Don for inviting me for 1 month as a visiting scholar at NKUST. I think I have some different kind of presentations. Actually, I prepared 4 presentations. Now I combined into 2. So I try to use some insights about various methodologies, not much focused on the results. So this covers almost whatever the techniques which are used in the last 15-20 years. So starting from my PhD to the current date. So it is combined, it's not specific to any particular process, particular product. So to make the methodology sequence, I combine the information from various results. So as a given the topic, I start with this macroalgae biorefinery for biofuel production. So I hope it is audible. As a professor said, myself Oscar working as professor and the Department of Biotechnology at Central College of Engineering, Chennai. So ours is one of the leading engineering college in Chennai, in the region of Tamil Nadu. We are one of the top 10 ranked college. We offer 13 UG programs, 3 BTech programs, 7 PG programs, ME and PhDs in all engineering departments, including MBA. So we are affiliated with the various accrediting agencies in India. So we have a group of institutions, we have engineering institutions in the same campus. So I completed my UG and engineering in 1999. So then I worked in a college as lecturer for 5 years. Then I did my master's in industrial biotechnology from Annam University. That is one of the oldest university in India. It started about 100 years back. So then I joined as assistant professor in Chennai, and I did my PhD in Bioprocess engineering from Annam University, Chennai. So I completed my PhD in 2000. So I started my career in teaching in 1999 as a lecturer in chemical engineering department. Then I did my master's in nuclear. Then I moved to the biotechnology department at Central College of Engineering. I joined here in 2006 as assistant professor. Then I got promoted to associate professor in 2010, and then I got promoted to professor in 2013. Almost this September 30, I will be completing 10 years as professor. This is my 20th year of teaching in teaching profession. So started in 1999. So this is the 25th actual year. So this is my research outcome. So from Google Scholar, the total citations 4,517 and in Scopus total 177 documents in text with the index of 29, and in Web of Science 140 documents in text journals and total 158 with the index of 28. So these are my research area, and the focus on this research area and different time during this last 18 years. Suppose I started my research on producing therapeutic enzymes, therapeutic proteins. Okay, then this theory using fermentation. So we produced asparaginase, so therapeutic enzymes for anti-cancer treatment. Then after PhD, we focused on formulating this asparaginase as a nanomedicine and tested for drug delivery and analytics applications. We found nanomaterials and biomaterials. And we produced HR and nanocatalyst. And currently we are focusing more on biofuels, particularly bioethanol, biodiesel, and using the remaining residues for as byproducts for other applications from municipal wastes, from agricultural residues, from microalgae, and we will done some work on non-edible vegetable oils also. So later we started focusing on technical analysis of the various processes, particularly did technical analysis on biodiesel production and bioethanol production. And of course I started with design experiment responsible risk methodology during a master's in 2005, and for some time we stopped using the design experiment because it is considered the oldest method and for 10. So now due to the latest development in computing technology, is artificial intelligence, machine learning, where the design outputs from the design experiments are used as the input for artificial intelligence and machine learning to develop more and robust bioprocesses. So now again we started focusing on design experiment, artificial intelligence and machine learning. So we try to cover most of the these cases. So far 13 PhD scholars completed the PhD on related titles. Currently 8 scholars are doing the research, and 14 master students completed the research work and working in progress, and more number of undergraduate students. So totally 196 publications. The contributions managed by PhD scholars and master students. They edited 6 books for Elsevier and Springer, and then each of us delivered various medical classes, and presented our research in many international conferences. So this is my major topic given, but I wanted to shift from this topic to some other topic. It's kind of changed. So this will be my presentation. So for this actually I present prepared 3 PowerPoints. Now I combine into 2. So I want to move to another PowerPoint. So this will be the outline of my presentation. So we'll start with the first one. So this is my first presentation. Here you will see optimization of many processes, okay, by studying the impact of influence of various parameters on a particular process to make your product. So though it is here mentioned fermentation media components or process medicines, you can apply this for anything. Here, of course, responsible medicine methodology, that is part of design and experiment. This serves as the basic approach method. The data is used in artificial method combined with genetic algorithm for better optimization than RSM. RSM is a design optimization strategy method. So now recently we started applying machine learning algorithms for optimization of processes. Okay, so it is reported more efficient or more costly. Of course, I started working on this RSM and AIM during my PhD. So that's why I want to mention here. Okay, so we focus more on RSM, AIM, and kinetics. So as I done my PhD from analysis China. So the professor Ranganathan is now he is the professor. That time he was the assistant professor in 2008-9. So now he is the professor in the biotechnology. So I started working on the cells and asparginase during my masters and PhD. So So as I said, this asparagines is a chemotherapeutic enzyme. So it is used to treat particularly blood cancer. So it is reported for the chemotherapeutic application which last 2 to 3 decades, from 80s and 90s. So I thought of working on some medicinal products. So I searched literature and started my research work in doing masters on this. But for last 10 years, forget about this after PhD. So now I started working on this in last 2 months. So in this area, so asparagines is not only a chemotherapeutic agent for cancer treatment, it is also used to treat the starchy food products before frying. So therefore, the side effects of consuming fried products can be minimized. How means this asparagines, if your food product is soaked in asparagines enzyme for some time, so it will reduce the asparagine present in your food products. So therefore, during frying, this asparagine cannot react with the carbohydrates present in your food. The reaction between the asparagine and carbohydrate leads to the formation of acrylamide. So acrylamide is the carcinogenic material. That's why, particularly in India, South India, did not prefer the fried food. Just when the food is fried at high temperature in the presence of oil, the heat retention ability of the food is increased. So it will be retained for a longer time, particularly when it is heated above 120 degrees Celsius. Say if it is 130, 140 for 5 to 10 minutes, your food product, starchy food product, will become more, initially it will become golden color, then it will become more brown. If it is more brown, it will be tastier. That is because of the Maillard reaction between the asparagine and the carbohydrate. If it is more brown, that means it contains more acrylamide. If it is more acrylamide, above the limited minimal ppm, then it will lead to the carcinogenic effect in individuals because of individuals. So after my PhD, we applied for a research grant from Government of India, Department of Biotechnology. We obtained 25 lakhs to do a research work on therapeutic applications of asparagines. Yes, during my PhD, I focused only on developing a bioprocess for producing increase in the yield of the asparagines. And meantime, we applied for a fund from Department of Science and Technology, Government of India. We obtained around 30 lakhs to test the effect of asparagines on mitigating the alkaline formation fried food. So in European country, this asparagines is commercially used in food industry to reduce the alkaline formation. But in India and other developing countries, we are not concentrating or concerned about the side effects of food products. So we focus on the taste and the quantity and not the quality. So that's what the introduction I wanted to say why we focused on asparagines. But my presentation aim is different. Here, so this presentation is mainly focused on how the artificial generator linked with genetic algorithm and machine learning techniques can be used to develop better processes to enhance the output. So using this response-based methodology, we can form a combination of experiments, minimal number of experiments. Using minimal number of experiments, we will be able to study the effect of these parameters on the output. At the end, we can find the best input conditions to get maximum output, particularly in process systems. In some other case, it may be best conditions for minimal output. So these statistical methods is considered as more advantageous because with the minimal number of experiments, okay, with the minimal time, minimal usage of chemicals, we will be able to study the effect of various parameters and find the best conditions for maximum output. So there are so many research works are reported available during particularly 2015 so from 2005 to 15. So during that 10 years, you can find more number of research articles using design experiment, statistical method, responsibility standards. So for the Blacker Berman design and under composite design. So this Blacker Berman design and Center compound design are some of the statistical methods. The Blacker Berman design is particularly used to screen and identify the important parameters in a particular process when you have more number of parameters. Say example, if 15 parameters influences your process, okay, we may not know the relative importance of this parameter, which are the important parameters, which are the least important parameters. Using Blacker Berman design, it will form 10 to 12 experiments or 15 experiments. Okay. By conducting this short number of experiments and analyzing these results using statistical methods, you can identify the 3 most important parameters or 4 most important parameters. So we can select from the literature, but always the parameters which you obtain from the literature may not be perfect for a particular process. Your particular microorganism may be different, your product may be different, your process conditions may be different, your reactor may be different. So then after finding these 3 most important parameters or 4 most important parameters or 5 most important parameters, then we can make another set of experiments for these 4 or 5 selected parameters, okay, and study the effect of these parameters on the output. Okay. Then we'll be able to find the actual values of these selected parameters. Say example, temperature means 30 or 31.5 or 32 or 32.5 exact value. pH 6 or 6.5, 6.1, 6.2. So exact values we can identify, that is called optimum values for the maximum output. So that is done by the response-based methodology, box-Berman design and center composite design are the sum of the response-based methodologies. Each method has its own merits and limitations to the particular process. By selecting the particular method, you have to see the its suitability to the particular process. And it is considered here the efficient method when compared to the one-factor optimization, that is called classical method. You may study the effect of temperature like 30, 35, 40, 45, 50 by keeping all other parameters constant. Okay. Then you find the actual temperature, optimum temperature. Then we go for fixing the temperature, then we will adjust the pH or time. That is called the classical method. Here, in one set of experiment, we will be able to study the effect of all these parameters. Okay. So when compared to classical method, it is considered best method. So particularly during 2005-10. So it follows, I think there are a lot of books available on this background. So here the number of experiments, N is the total number of experiments. It may be 20 or 30 or 32 or 31, capital N. That is equal to 2 power N plus 2N plus K naught. This small n is the number of variables, input variables 3 or 4 or 5. Okay. And K naught is the constant. It represents the how many repeated experiments are done at these center points. So depends upon this, the number of experiments will be different. So this number of variables small n, say example temperature, here we may select from the low temperature, high temperature. That low means -2 or -1, middle means 0, high means +1 +2. Okay. That means if you are studying the effect of temperature, we may study between 30, 35, 40. Okay, 35 is 0. Because in the statistical method, we should use only the coded values for statistical analysis. Say if it is pH is 5, 6. We know it ranges from 0 to 14. The temperature, so maybe hundreds or 50, it is coming across 500, 600. So the numerical values are different. If you change the temperature from 100 to 150, and if you change the pH from 5 to 6, the effect may be same. But here we are changing the pH for one numeral value. In temperature, we are changing 50 numeral value. If you use these actual values, its influence on the output will show in different say level. So to normalize this, we use only these coded values. Okay. So if you study some literature, you can understand this. So in response-based methodology, the influence of various parameters, selected parameters on the output is after. So in response-based methodology, if you select these 3 or 4 parameters, and if you give these parameters and these minus and plus values, it will generate a set of experimental design. Then you conduct your experiment. Then give these experimental results into the software. Then do the statistical analysis. Then you develop a mathematical equation. So this mathematical equation represents the influence of all these parameters on the output. And it is represented by this polynomial equation. So y equals capital Y is the output variable, maybe yield of the algal biomass or yield of lipid or any particular product. Okay, and where B naught is the coefficient, all other. So this is like a polynomial model. Y is equal to m plus say ax and say bx. If you have x1, x2, x3, x4, bx1, bx2, bx3, and then bx square, interaction effect, or there is quadratic effect, and interaction of this last one, say x1, x2. So it will form a mathematical equation. Then during that time 2006-07, we had to solve this mathematical equation manually, or using a matrix equation mathematical concept, or using MATLAB. So nowadays the software used to for this. Say here it is mentioned Unitap coding, and there are other softwares. The latest software incorporated this step also. It will automatically solve this mathematical equation and it will give you the output. So this is one approach of optimization that is considered better than the classical method. And then artificial neural network is found to be more useful than the response-based methodology. Here the input data for this artificial neural network is the data from the statistically planned experiments. Okay. So that the results obtained in the statistical approach, the response-based methodology, are analyzed using an artificial neural network. Okay. Here the artificial neural network it operates like our human brain. It has the capacity of conducting more than 1 lakh iterations even within a minute. So in statistical method, it will study only 30 or 32 interactions. Here it will study using the data, it will study more than 1 lakh interactions in 1 minute or 2 minutes or 3 minutes. Okay. And it will extrapolate the variables also. So it is considered sometimes, it depends upon your process. For some process this may be more efficient, or some process response-based method itself may be more efficient. That depends upon your process. But in the methodology approach, in terms of methodology approach, this is considered as the latest one when compared to the response-based methodology. So artificial neural network is incorporated with the response-based methodology to improve the efficiency of process optimization. So it is a mathematical understanding of the neurological function of the human brain. It mimics the function of the human brain. Within this, there are so many algorithms. Okay, like somebody's brain may work like ant, somebody's brain may work like honeybee. Okay. So we have the ant algorithm, honeybee algorithm, like that. That's what I wanted to say. Particle swarm algorithm. So there are different algorithms in artificial neural network that mimics the functioning of the neural network at different level. But here in response-based methodology, we get mathematical equation. Here we will not get the mathematical equation, physical equation. Okay. It will understand the interaction between the variables. It will develop its own model. Okay? It's not in terms of the mathematical equation. Okay? And it will give the results. We can compare the performance of the various algorithm within the artificial neural network. We can change the different algorithm and run the network, so run the program, and we can compare. And we can compare the artificial neural network and responsiveness methodology also in terms of root mean square value, or in terms of the R-square value, and in terms of your output also. So our aim is solely output, not in terms of root mean square value or R-square value. R-square value may be higher. If it is higher, we can say statistically it is correct, it is better. But we should compare the result also, your yield also. So this mimics the brain learning process by arithmetically modeling the structure of interconnected nerve cells. They consist of an input, one or more hidden layers, and an output layer. This hidden layer helps to make more iterations. So the neurons in the hidden layer are linked to the neurons in the input and output layer by adjusting the weights. That is the difference between the input and the output. Then it will form a new combination. Then it will run. Okay? Like that it will repeat for so many times. So enable the network to compute complex relation between the input and output variables. So after running this network, it will understand. So what do we think? We will get some relation, some idea, but it cannot be mathematically transformed. Like that in the artificial neural network, it will understand and it will give the results, but it will not represent the mathematical form. Okay? So it will understand between the input and output variables. The ANN performance can be determined by R-square value, root mean square error values. So here, in our work, we used artificial neural network. It is proved to be useful in media optimization, combination media components, maybe combination media components, or combination process conditions, or any other methods like if you are synthesizing nanomaterials, so the concentration of precursor, time of synthesis, and sometimes maybe pH, or sometimes maybe the concentration of the reducing agent used, and stirring speed or time. You can select any method, not only for synthesis of nanomaterials, even in the engine performance studies also. Different combinations, okay, different time, different speed. Okay. So any parameter. You have some process, it may be mathematical, or sorry, it may be mechanical or chemical or biological process. So yeah, any process depends upon the performance of any process depends upon some input parameters. You select some input parameters, fix their values. Okay, based on the literature and from your understanding, you can fix the closest value, okay, and then you can find the exact value for the maximum output. So that is the idea of the RSM, ANN, and ML. So the ANN is proved to be useful in media cross condition optimization. So of course this work was focused on L-asparginase protection. So we test the L-asparginase productivity in terms of its activity. We used center composite design, okay, and then the same data was used as was fed to the artificial neural network linked to the genetic algorithm. So ANN is trained using 2/3 of the total data. So there are 3-4 steps in ANN. Okay. First, it will train itself by taking some set of data. Okay. So we have to give 2/3. Some percentage we can fix 80, 60, or 60, 70. Okay. It will train itself to understand the effect of input variables and the output. Okay. And then it will validate itself by comparing with the remaining set of data. Okay. So and then we will give our sample data, then it will give the actual values. So ANN is capable of predicting outcome for new input data similar to the pattern that was trained. If you train and validate, then the trained and validated neural network algorithm and its settings can be used to find the better input values for your maximum output. Okay, that's what mentioned in the last step. So genetic algorithm is the combination of artificial neural network. So in artificial neural network, it will understand the relation between input and output. Then it will create some algorithm, some logic. Okay. But it will not give the exact optimum value for your maximum output or minimum output. So then these results of the artificial neural network is given to the genetic algorithm. Okay, where this genetic algorithm will use this model developed by the artificial neural network. Here also there are different functions, different algorithms. Depends upon the algorithm, its efficiency will be different. For your process, we have to change the algorithm and we have to identify which algorithm is best for your process. So then, using this genetic algorithm, we can find the exact value of your input parameters for your maximum output. We can find the maximum output also. The exact values determined for your maximum output is called optimum values. So it is called predicted optimum conditions. You get the predicted optimum conditions and its predicted output. Then you conduct a new experiment on this predicted input conditions, okay, and test the output and compare your actual experimental output with your predicted output from this technique. If it is closer, so if you are getting some, say, 40 mg per ml, say example, if the ANMGA or RSM release 40 mg per ml or certain conditions, say temperature 31.5 or pH 6.3 and 150 rpm or 150.6 rpm something. So we can get the optimal condition in terms of fractions also using this RSM and ANM, whereas it is not possible in classical method. So then if your experimental results obtained at these optimal conditions are closer to the predicted result, then we can say this methodology is working for your process and it is efficient. Otherwise, though it is technically sound for computer engineers or statisticians, it fails in your system. So you should validate with the experimental conditions. So if it is experimentally true, then we can say it is good. So genetic algorithm is a search algorithm inspired by the Charles Darwin's principle of survival of the fittest. So it will identify its best conditions for your maximum output. That's what the concept from the survival of fitness is identified. To solve complex optimization problems. Genetic algorithm gives optimal solution for global maximum output. Solution is represented by chromosome consisting of several genes. Okay. So during successive iterations, the initial chromosome advances towards stronger chromosome by reproduction. So that means for better output. So new generations are created by 3 genetic operators: selection, crossover, and mutation. Every time it will run, and if the output is not satisfied, then it will make new crossover, new combination. Then it will run, it will mutate, then it will find the output. Like that, it will go for so many iterations, then finally it will give you the output. So this is what the work actually we have done. So we have taken the 4 different parameters, say proline, sodium nitrate, asparagine, glucose as nitrogen source, carbon source, and amino acid for my enzyme coordination. So this, I don't want to go in detail on this. This is the part of PhD work done during 2007, sorry, 8, 9, 10. So some of you may be familiar with this table. Okay, see here we have selected 4 parameters, and here we have the number of experiments. Okay. I think goes up to 30 or 40 depends on the number of experiments. It is not ended with 20. We have more. Okay. So for example, I have given the short table. We have these 4 parameters selected different values. These are the -1, +1, 0, represented in actual values. And these are the actual your experimental results obtained for this different combination. And then we given these results, experimental results and input to the RSM, and we predicted these results. And we given these input variables and experimental results in the ANN, we predicted these results. So this continuation for this selected 4 parameters we have 31. So the number of experiments depends upon the what type of say RSM you are using. So you may select box parent design or say center composite design, and you may go for half factorial design or full factorial design. Depends upon that, the number of experiments will be different. And these are the table, t-test table and f-test table to statistically analyze your response service results. So this is not the objective of today's presentation. But using this, we can find the influence of these various parameters and its significance in terms of p-values. So here the significance tested at 98% confidence level. So the p-value is less than 0.005. You can say it is significant. Here the first, these are the linear. This represents the linear impact, and this represents the Anderson effect, the square effect, and then interaction effect. So this table is used. Sorry, I think it is difficult to complete in time. We'll try. At least we cover ANM and ANM. So this data given here is x1, x2, x3, x4 and this experimental output. Okay, is given to the neural network to train the selected neural network. So I think you know this. Sorry. So this is part of the RSM. So this is the polynomial equation, and next one is ANOVA test or test results. So this is what I mentioned. Earlier we used to solve this equation in using matrix translation, okay, or matrix inversion technique. Then we can solve using the MATLAB program also. But now you see here in the Minitab itself, this option is available. Okay, you can get your optimal results. So the center one is optimal results, okay, for your maximum output. Maximum output is 19.12. So this is just for example. So this work is different. Here this result represents only 3 parameter, not the 5 parameter. Okay, so now this is the artificial neural network. So we selected some algorithm in the artificial neural network. Here in this work we have 5 input variables. What are the input variables we have selected as part of a response of this methodology? Okay, input variable. And this one is the output. Maybe biomass yield or product concentration. And here maybe the inoculum volume, okay, and temperature, time, pH, substrate concentration, whatever for the parameters, or the RPM. Okay. You can select 3 or 4 or 5. Okay. If you are unaware of the what are the important parameters to be selected, then you can go for Plager formalization or from the literature. So in artificial neural network, so this forms a hidden layer here, the network. This hidden layer helps to make more combination of these input parameters. Okay, you see, these input parameters makes more combination here. Okay, not only one set of combination. Then after the one set of training, it will compare the output with the input output and input variables. So that means your predicted output, original output. Then if the deviation is more, then it will form a one constant that is called bias. Then it will compare with the bias and try to reduce the error, try to reduce the difference. Then it will run. So it will repeat for more than 1 lakh times, iterations. By and it will try to decrease the difference between your experimental value and the predicted value. So there are, so we may have the one hidden layer or 2 hidden layers here. If we go for more hidden layers, it will be more efficient, but it will be difficult. Because in the statistical method of optimization, we used to have 20 experiments or 30 experiments. If the number of experiments are less, then ANN will be more inefficient. So artificial neural network requires more number of input data. It not necessarily be from the statistical experiment, maybe from your one factor optimization also. If you have the combination input variables and its output variable, then we can run. But the more the number of data, more will be the efficiency of artificial neural network in predicting more results. So sometimes when we submit a manuscript to the journals, they ask this may underfit with your data because your data is less numbers. Okay. If your data is less number, then we have to select a suitable hidden layer and suitable algorithm. Therefore, the Though the number of experiments is less, it will give you a efficient result. So here we used the artificial neural net with the back propagation algorithm. There are so many algorithms, so many transfer functions, and 4 input neurons, 4 hidden neurons. So here we have 5 hidden neurons, 5 input neurons, 4 hidden neurons, and 1 output neurons. Neuron is nothing but the parameter, input parameter, output parameter. So then, so this is for training. It will train the neural your selected network with some data. So, and it will compare with your input and output. Okay, and it forms a linear line. Okay. So after so many iterations. So this linear, you have hatched line, but it is not there because it fits more closer to the linear line. Okay. So y is equal to t. That is the like linear line at 90 degree. And blue color is the fit. So it is closer to the linear line, therefore you are not able to see. And the small circles are the actual data. See here the R squared value is 0.9999. It is closer to the 1. Okay. That's why all this actual line, straight line, and the data are in a straight line. So this is for training, 2-way pair of data or selected percentage. And then for testing, for the remaining set of values, see here the number of data is less. Say 2/3 is used here, then 1/3 is used here. Okay. Then for this also is develops here R squared value. For testing, since we have this number of data, the R squared is 0.933. Then if you give another set of input parameters, then it will validate the model. It will cross check and validate for a set of given data. Then it will compare, it will run again for all these data here. So all the data. Okay. So this is the graphical output from artificial neural network to test the efficiency of your selected artificial neural network with the selected input parameters on feeding your output variable. So using this R square value, you can compare with your statistical method and then you can find which is best statistically or mathematically. But we have to confirm with your experimental results also. So from this ANN, we will be able to identify what is the relative importance of the parameters. So among the selected parameters, D is the most influential parameter, of high impact, and A second most important, and B is the least impact parameter among these parameter study. That also we can understand. And here we can get the actual values. So that is predicted value for A, B, C, D, E are given. And this is the 25.39 is the predicted output, okay, for these conditions. So this is the actual result we aim from the artificial neural network. So at this A, B, C, D, E, it says you will get 25.39 output. Okay. Then you conduct the experiment at these A, B, C, D, E conditions and test your output value. If your output value is closer to this 25.39, then we can say this approach is okay. The results obtained is reliable and the results are okay. We can say this method is efficient in optimizing your process. So here this is for comparison. These results are from different. From RSM, for some conditions we have 35 experimental values, on ANN 36.9 experimental values. Sometimes these two may be very closer or very higher. If it is very high, the productivity is very higher than the ANN, we prefer this very higher than from the RSM, we prefer the ANN. So it is compared statistically using this R-squared value. Then we should compare with your experimental results also. It should be validated experimentally. So this is the predicted values, and after getting this predicted value, you have to conduct the experiment and confirm the results. And this is for statistical validation, this is for experimental validation. As I said, the results in the different slides are different. So in conclusion, from our study, we concluded artificial neural network linked with the genetic algorithm is more efficient than response-based methodology in optimizing our process. And we found increase in the aspergillus activity by 23.58% than classical method. When compared to RSM, it may be 5%, 10% or 3%. So for this ANN linked genetic algorithm, we used neural power software. If you are familiar with MATLAB, you can use MATLAB also. On the neural solutions, so there are so many softwares are available. Neural power, neural solutions, or MATLAB. MATLAB is universal software used for various model instrumentation studies. So these are some of the research work we have published. So during 2011, 12, 11. So actually I wanted to present on the Algal Biorefinery, but I thought of giving some information on ANN and ML. Okay, now we move to the machine learning. We started working on this. Because of the latest development in machine learning, now again we started working on RSM and ANN. Otherwise we are not working on RSM ANN for last 10 years, 12 years, after my PhD. Now we are taking the results of my PhD and we are working on the machine learning. We are applying machine learning techniques to validate our results again. And this machine learning will give you the results in fractions of minute. Say in 10 seconds it will give you results. But ANN may take more than 1 lakh iterations. It may run for say 5 minutes, 10 minutes. And here we have more robust algorithms, okay, and it will be more efficient. So the software which can be used for this machine learning in Bioprocess applications, we can use again MATLAB or the Python programming. So since we are not familiar with Python programming, we are getting assistance from the information technology or machine learning development. We have artificial intelligence and machine learning and electronic system development. And we don't need to depend on them for the Python programming or R programming. There are some open source software and GUI software like Veka. Recently I attended one workshop in the last Saturday, Sunday. So I learned so many things. It focuses not only on gene sequencing and comparing the data, predicting your protein structure of your molecule. Then Veka can be used for optimizing bioprocess also. So just attended this NPTEL. This is the NPTEL course, NPTEL workshop. Veka. It is organized by the professor from IIT Madras. Since it is a workshop, they will schedule and organize. You may check the NPTEL website and they schedule you can participate. The research may be around 2,500 INR to the workshop. So already we started using Python programming with the assistance from the other faculty members. Then I thought of training by our own, so that's why I attended this Veka. So machine learning models can be trained on data generated by statistical experiment from responsible methodology to predict optimal cross conditions for maximum productivity. So the oversampling method is used to stretch the data for implementing the machine learning techniques to enhance the data or to get more accountable output. So this means oversampling means, as I said in ANN, here also you have the less number of data, the ML will not be efficient. So in ML, we have some technique. If you have 30 data, then using some oversampling or stretching approach, we can generate more data in between. So 30 data can be converted to 100 or 150 data. It will develop. Okay. It will extrapolate and interpolate. It will form more data. Then it will use this own generated data also for training. Okay. That is the advantage of machine learning than ANN. ANN cannot generate its own data. Okay. So here the machine learning can generate data from the given data. So if you give, say example, the numbers 35 and 40 in response of this methodology, it will generate data for say 36, 37, 38, 39 also. Okay, like that. So here in machine learning, so different algorithms are used, random forest algorithm, Bayesian tree algorithm, and linear algorithm, so many algorithms are there. We tested with the different algorithms in the machine learning. So the predicted conditions are compared with the RSM and ANN, comparing solutions. Here also like ANN, some percentage of input data, say 85% input data is used in our particular study and what we conducted already. So we may fix from 63%. to 90%. For training, 10% data for testing, 5% data for validation. You see here, so like already said, we had 5 input variables and your experimental results, and this is your RSM predicted result, this is your ANM predicted result, and this is the ML predicted result for each of the experiment ML predicted. Similar to AN also, for this also we get this plot, comparison plot, say experimental value and your predictor value by this ML algorithm. So this is for the random, I think random forest algorithm. For training set of data, and testing set of data, and for validation and for all data. So this data is different from the whatever this is shown in the ANN. So you see here there are some deviation in the parameters. The ANN, all the parameters in the line, but this is for different set. So by comparing this, you cannot say here the ML is not good, ANN is good. So this is for different set of data. Okay. For that data, we have not done the ML. So here we get the R squared value and root mean square value. So therefore we can compare the performance statistically. So the closeness of the experimental data and the random forest algorithm predicted activity in training, testing and validation and all data are shown in this figure. And root mean square value and regression coefficient values of this algorithm are compared, and it is given in the next table. See the root mean square value, RSM value, root mean square value for random forest algorithm was 1.14, 0.79 and 0.84 respectively for testing, training and validation. And if you select the more algorithms within the ML, then we can compare the results and we can identify which algorithm ML is better for your process. Or if you have some literacy data from the literature, you can select. So here we have the regression coefficient. Sorry. So ask the values. So this data goes from the previous graph and it is listed here. So for testing set we have used two algorithms actually. So I have shown only the graph for the random forest efficient tree. You see the there are slight difference in the R-square value, slight difference in the RSM value. Low RSM value is preferred and high R-square value is preferred. The R-square value can be maximum 1 for testing data, training data and validation. You see from the validation, so this random forest have the high R-square value than vision tree and high low RSM from the vision tree. So we can conclude random forest algorithm of ML is better among the other ML algorithm tested. So these are the results we obtained. So this for different set, the new set. See RSM is 39, so predicted experimental after validation. This is predicted by the software and it is validated. On ANN, so this is given only for the understanding, so not the exact values, it is from the different set. So it is to understand the methodology. So ML using random forest approach, it is say different. Even we can compare the parameters also. The temperature is slightly lower, that is preferred, that will save the energy. So cost of the process will be less, say here 31, 32.7. And see these parameters and the output. Though there is a slight difference in the output or same output, if the parameters are more favorable, then we can go for this method or any method. So parameters should be more favorable or economical, okay, and the output should be maximum. So from this work we can conclude random forest algorithm of ML predicted the combination cross conditions so and so, okay, and with the experimental activity of 1.58. Thus we can say ML algorithm ML using random forest algorithm is better than statistical or AN. So for this we used my PhD study and conducted this ML work recently with the help from the other departments. Time permits, we can continue to the my macroalgae biorefinery, otherwise we can
It's enough. Because I need to know. Thank you.
Currently we are working on bioprocess. Currently we are working on biofuels, bioenergy, not much on this fermentation, much on microbiology. Although we started with the fermentation laminar route, now we are not working with the laminar route. We are working in the reactors and waste to energy or astute energy. Okay, thank you. So I thank Professor Pandey and Professor Dan for the opportunity.
Thank you so much, Professor, for your presentation. I have also written a review article published in Stotel, but I really want to work on this machine learning aspects and ANN. I just wanted to ask, like, if we want to learn these techniques, like we already have been using RSM for a long time, but I want to inculcate or introduce this machine learning in our lab. So can you help us in, how to use these? Are there any specific softwares we need to purchase or download? And how much time do we need actually to learn the basics about machine learning techniques?
We have some basic understandings, then we can learn thing in 2 weeks or so. Okay. But for PhD scholars, it may take 2 months to 3 months to understand. Because they need to study the literature, understand how the techniques can be applied for their process. So, then they should study the basics of ANN or basics of ML. Otherwise, you cannot apply with confidence. You should understand the basics. Then only we can select the suitable parameters, suitable numbers. Because during my PhD, we submitted one paper, we got lot of query. We don't know what is it. They asked underfitting, overfitting. I don't know what is underfitting, what is overfitting. Then I contacted so many people. That time we used to study the ANN as a subject, like how we study ML as a subject. But nowadays, before studying, we are understanding its applications like AI, ML. We are using its applications, but without understanding the concept. But that time we used to study the ANN only the subject. Then I connected with one professor who is teaching ANN. He given his material, lecture material. Then I studied the basics, and I understand underfitting means if the number of data is less, then it will go for underfitting, and how to work on the underfitting. Then we cannot change our results across already we completed. Then we identify the reasons how to work on the underfitting and what will be the negative impact due to the underfitting. Then we prepare the response. So it may take, depends on the person to person, maybe from 2 weeks to 2 months, 3 months. But once you complete one particular work, then only you will understand the half of the concept.
So like, just like we have softwares like Design Expert, Minitab for RSM based so do we have softwares for these so that we can have access to them? And maybe since you are here for the next 2 weeks, maybe you can teach 1 or 2 of us so that we can then.
So so we can use MATLAB as a universal software for various applications irrespective of the particular field of study. It is a paid software, if you can practice, but I am not familiar with the application of MATLAB for these studies. So I use this MATLAB some programming during my masters. And then we got so many GUI based softwares like Neural Power, Neural Solutions. So these are the paid softwares again, but if you download, you can practice using free trial. Maybe for 1 month, 2 months, then you can understand. Then if you become familiar and if you are confident, then you can purchase. So currently these softwares are not in my laptop, but if you come, you can download and you can try it. So as I said, I am not working on this ANN GA for last 10 years. After my PhD, I stopped working on this RSM and ANN GA. But recently, some people said to me, apply ML in optimization. Then I took my data from PhD work. I given to the some people who familiar with the ML Python programming. We have done some preliminary work. Then now I thought of applying this ML in the bioethanol and the biodiesel production process. So currently we are working on biofuels naturally with microalgae and macroalgae. We will try to incorporate these techniques in our current study also.
UFQC data was good enough for machine learning. You need maybe multiple other data that to blend with and
So that they said that data is enough. By using smoothing technique, they can generate more data by extrapolating and interpolation, extrapolating interpolation techniques available in the machine learning. They can generate more data, and therefore they can make it, the ML is efficient.
as you mentioned in one of the slides, like 2 or 3 data can be submitted to KNN.
So if you have some set of data, say exam 100 data, 70% of data maybe randomly picked and used for training your neural network to accommodate, to understand your data. Then we can use the remaining 20%, 20% to cross check risk testing, to cross check the efficiency of the trained model network. Then using the 5% of data, then we can validate. We can get your output. Then all this data can be given to the trained model, this information can be given to the empirical algorithm, then it will give you actual optimal values. This we have used some time back. So we used neural power actually for our studies.
Thank you for the I would like to ask about the so the acrylamide is a potent carcinogen. So what about its effect on the antibiotic, like antioxidant foods? So what is the difference in antioxidant foods for this acrylamide?
So on the extent, there should be no acrylamide.
But in like when we try the food, you say that the acrylamide concentration increases. So if for example we are giving the high temperature to the food that are rich in antioxidants, so what
Okay,
happens to that?
right. So, but if your food though it contains more antioxidants, if it contains high carbohydrate, so then normally food will have the asparagine also. During high temperature heating, maybe frying or any other conditions, even wet conditions also. So if it is heated to high temperature, say more than 120, say around 180, 140, some 10 to 15 minutes, okay, this asparagine will react to the carbohydrate molecules. That reaction is called Biorefinery reaction. So that forms the brown compound. So though it is antioxidant food products with more antioxidant properties, if we have carbohydrate, then this reaction will happen. So then we need to reprocess your food using this not only asparagine, there are some other methods to minimize the reaction between asparagine and carbohydrate. That's why we soak the say French fries or something, we soak it in the water for some time, then we go for frying. During that time what will happen, asparagine will be washed. So there will be no asparagine, asparagine, you cannot say no, asparagine concentration is decreased, it is washed. So then we can prevent or minimize the reaction between asparagine and carbohydrate present in a food product. We don't want to lose the carbohydrate, but we can try to remove the asparagine content, therefore we can minimize the carbon reaction and form this product. So that's why we used to say starchy food products.
Yeah, can we prevent and can we minimize these things like by using one time fried oil and then not reusing it again and again? Because that is very...
that is also possible. We can prevent the increase in the acrylamide concentration in your another fresh product. But though it is one time frying, though you use a fresh oil, so when it is heated to high temperature and it is a starchy product, it will form the acrylamide. In all fried products, acrylamide is there. Okay. Only thing is the concentration is above the minimal level and depends upon the individual, the side effect possibly will be different. So we have more chances of getting the side effect in the immunosuppressive patients or if your process is not good. We completed this product in 2018. We used HPLC 1260 engine to estimate this acrylamide. Then we moved into the bioenergy biofuel. Still some UG students are working on this. forming a nano biocomposite of this asparginate and other anti-cancer nanomaterials. We are preparing a nano, that's why I mentioned nano biomedicine or nano biomaterial. We prepare this nano biomaterial with a therapeutic protein and some therapeutic nanoparticles, and we study its therapeutic efficiency with some cancer cell lines. So that is short term students able to complete in 1.5 months, 2 months. We go for at least one publication for these students. They are interested.
Okay.
Thank you, Professor, for your presentation. I trying to using the RSM for my experiment, and I have some like result. I can explain. Can you back to the slide number 12? I mean the next one. Number 12. Yes. Yes, sorry, sir. So I using like also like four variables like x1 to x4, but I also have like kind of the same result. I mean the single variable is not significant, but
Not
the,
significant.
yes, but the like the multi like integrate of like x1 or x2 or square of x1 is significant. So in that case, like what can we understand of those results? Like the single is do not affect on the
Since
response.
the say X1, I think when we say temperature, the interaction effect we cannot eliminate. That's also a significant variable. But in the interaction scale, so there's a significant influence. So that's why it's selected this table. In other table, we have got all the values. Most of the values are less than 0.001. But when it is process conditions, operating in process conditions, so the significance may be different.
Actually, Professor, what he wants to, and what I understood is, he says that if something is like values are less than what you are saying, P value lesser, and then it is significant. That means what we can say about it? Like these interactions are not significant. Those are not important.
Difference is what these parameters we should look more into
More
that.
depth.
Okay. And whatever the parameters we can say selected is having the impact on
On the
product. If on many of these parameters are not significant, then there is no meaning of conducting this experiment. Then we can skip this. Okay. So we may go for some application, but it is not useful. So that's why before selecting the variables, you go for a thorough understanding and study of the literature, and if possible, you test with some one-factor studies or the Blocker permanent design. So in one process, as I said, L problem may be a significant for one particular process. For other process, L problem may not be significant. So from the literature, simply we cannot take. We can read the closest literature, then we try to identify.
Actually, this is more important. Selection of parameters.
Selection of parameters is more important.
If you select any parameters or the values, high values and low values are not important.
And selecting this range of the variables also important. So from the literature and from our own understanding, we know fermentation mostly will be between 30 to 40. If it is thermophilic, it may be 40 to 45. For thermophilic bacteria, we should not fix the maximum value 40. It may be around 45 also. In that case, you start from 35 to 45, 35 to 50. For your other microorganisms, we may study from 30 to 45. For thermophilic, we may start from 35 to 50, 35 to 45. But the temperature, we cannot fix more than 50. So selecting the range is also very important. Then selecting the parameters. Selecting the parameters and selecting the range of these variables are important. You cannot select the pH like 9 or 8 algal pH. That is logically incorrect, and if you want to do any results, then your results will not give any significant results. Statistically, will not be significant.
So before going to RSM, one should have.
So applying your understanding and knowledge of the biotechnology is important than the statistical. Don't believe only on the statistical method. It will assist only. It will assist you to get better results.
There's a student who here, but like who want to understand
Maybe,
better,
yeah.
he's
See,
there.
trying to maybe we discuss it.
Yeah, he's there in the fifth floor. You can come anytime and
Yeah.
Okay, thank you.
Thank you. I also need to go to. Okay, thank you very much. Okay, and finally, we have a seminar class starting from next week, and this week, this semester, I have already signed for six together. Six together, yeah. So hopefully all they can join the class. We will sign. But you will get the extra credit, but it's small credit because it's shared credit. 0.5 credit, maybe 8,000 or 9,000. Okay, but someone will get more, but depend on it. So we are shift because right now our PhD program just starting. We hope because focus on PhD, so all our professor and the second professor they can all working together to see how it's going. So I have some this six. But if you have the other conference, you can go. But some other charity you have to pay this semester. So you are corresponding. Then I assign this one, Eason will go. Because Eason this semester, you handle, and the other one, daily, Because you both you get one credit. The other four, So next semester we shift to the other one, okay? To handle this class. But I hope all they can join this class and to know each group. Beside me, I don't have credit for this class. But I hope to handle this. Just let me know in the future. So anything you want to make an announcement, Ethan can handle. So I must leave it. So tonight, I will leave dinner. Ethan will carry.
Thank you, Professor Dong. Thank you, speaker today. Very grateful. Thank you. Students, if you have any issue, they will stay here until the end of September. So, in the daily time, okay? If you want to have the discuss with this professor, you can come to the meeting B, okay? And Dr. Adiba is in together with us, so they might be there. But before that, please make an appointment with them, okay? So here now, thank you for you to attend this seminar. So you can leave now. I have some announcement to the student. Thank you. Thank you.
Student?
Student, please stay maybe a little bit.
We are also PhD candidate.
Okay. And Mrs. Kirby will open the light. Dr. Adiba, maybe we can have the picture together.